So, hi children, in the previous video we discussed up to prime numbers and composite numbers, right? So, in this video we are going to discuss about that Sieve of Erasthones method. So, why this method we are saying means how to identify that prime numbers by using this method. Sieve of Erasthones. Sieve of Erasthones. Okay, so what is this method and how to find? So here I am going to take that the numbers from 1 to 30 numbers I am going to take. When you observe that 6th class textbook, okay, state textbook, in the textbook they given up to 1 to 100. So I will tell you up to 1 to 30, the leftover 31 to 100 you check that one, okay, once you try that one. Okay, if you didn't understand this one, once again comment in that, again I will teach you this one. Okay, so see that here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And here 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So here I taken the numbers from 1 to 30. Okay. So just to say that already we know that 1 is neither prime nor composite. Okay, we know that one. So no need to consider it. So the starting number, which number is there, that number you have to just circle it. Okay, so the starting number, wherever starting numbers are there, those numbers just you have to circle that numbers. Okay, here 2 is there, so you know that 2 table now. Okay, so 2 multiples, just cross the 2 multiples here. Okay, 2 ones 2, so leave that one. Why? Because we are starting from 2, no, that's why circle that 2. So 2 2s 4, 2 3s 6, 2 4s 8, 2 5s 10. Okay, 2 6 12, 2 7s 14, 2 8 16, 2 9s 18, 2 10s 20, 2 11s 22, 2 12s 24, 2 13s 26, 2 14s 28, 2 15s 30. So just I crossed that only 2 multiples. Okay, so next one. So 2 after which number is there? I didn't circle, I didn't cross also, know that one. So that number is there, so circle this number here. Okay, now 3 table you have to consider. Okay, now 3 multiples you have to cross it. Okay, so 3 ones 3, 3 2 6, already completed, no problem. So 3 3s 9, 3 4s 12, 3 5s 15. Okay, 3 6 18 completed, 3 7s 21. Okay, 3 8s 24 completed, 3 9s 27, 3 10s 30 completed. So 3 table also completed. Next 4 table. 4 table means here 4 already crossed, that one already completed, so no need to consider. Next which number is there? 5 is there. Okay, now take that 5 table. 5 ones 5, 5 2s 10 completed, 5 3s 15, 5 4s 20, 5 5s 25. Okay, and 5 6 30 completed. Next 6 table completed here, already we crossed that. Next 7 table is there, so 7 you have to circle it. 7 1s 7, 7 2s 14 completed, 7 3s 21, 7 4s 28. Okay, 7 5s 35, but here 35 we didn't take, no, so leave that one. Okay, is it clear? So next 7 table also completed. Next the leftover one. See, once observe here, the leftover numbers we crossed that, except that crossed remaining numbers we circle those numbers. So first line completed. Now come to that second line. Here the starting number is 11. Okay, so start from that 11. 11 table you know that, right? So 11 ones 11, 11 2s 22, already completed, leave that. 11 3s 33, not given, so leave it. Next 13 table. 13 ones 13, 13 2s 26. Completed, no, that one also, so leave it. 13 3s 39, not given, leave it. So leftover remaining completed. Next is 17 table. 17 1 17, 17 2 is 34, that is not there no here, so leave that. Next 19, 19 1 is 19, 19 2 is 38, 38 not there. Next, remaining these two first two rows also completed. Now come to that next row. Okay, here the starting number is 23. Okay, so 23 table you have to write, that is 23 1 is 23, 23 2 is 46. So here 46 not there no, so leave that. Next, the next thing is 29. 29 1 is 29 and 29 2 is 58, that is not there no here, so leave that. Okay, now 1 to 30, I taken here 1 to 30. Once observe that all numbers are completed or not. Some numbers we circle, some numbers we crossed out. Is there any other leftover number is there without circle or without cross mark? Not there no. So once observe that 1 to 30, which numbers we circled here, those all numbers are prime numbers. Simply, which numbers we circled here, those all numbers are prime numbers from 1 to 30. Okay, so 1 to 30 prime numbers, which numbers are there? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Did you understand this one? Okay, so like this way we can write that prime numbers from 1 to any number. Okay, so 1 to 100 you try that one. I told you that 1 to 30 no, so you try that 1 to 100. Okay, after just comment that answer in that comment box. 1 to 100, how many prime numbers you will get? Okay, 1 to 100, how many prime numbers are there? Just comment that answer in comment section. Okay, so after that Sieve of Erasthones, so up to here natural numbers concept completed. Okay, once again natural numbers means the counting numbers are also known as natural numbers, and natural numbers denoted by the letter or it is represented by the letter, that is capital N. Okay, what is the smallest natural number is 1. What is the greatest natural number is does not exist or infinite. Okay, and in that concept only we discussed about that predecessor, successor. Okay, next even numbers, odd numbers, prime numbers and composite numbers completed. Okay, now we are going to discuss about another type of number, that is whole numbers. That is whole numbers. So whole numbers means what here? The set of natural numbers including 0. The set of natural numbers and including 0 are called whole numbers. Okay, so whole numbers represented by the letter capital W. So here what we have to write? This set is consisting of 0 and positive natural numbers 4, 5, 6 and so on. The set of natural numbers 1, 2 and so on, these all are natural numbers only, no? Okay, so the set of natural numbers and 0, okay, that set is known as whole number set, and the set of whole numbers represented by the letter W. Okay, so already we discussed now in that natural numbers predecessor and successor. So here my question is, which whole number is not having predecessor? Which whole number is not having predecessor? So which whole number? Yes, that is 0 only. Why? Because the predecessor means you have to subtract 1 from that given number. So here 0 is there. 0 minus 1 is equals to, again you will get that one as minus 1 only. Why? Because minus 1 here. 0 means nothing is there. From that nothing, what you will subtract? We can't subtract now. Again which number we written, that number only again you will get. So 0 minus 1 is equals to minus 1 only, no? Okay, is there in this set we are having minus 1? Not there in this set. That's why minus 1 is not existing in that whole numbers, no? That's why in whole numbers 0 is not having predecessor. Okay, this question also important. What is that? In whole numbers, which number is not having predecessor? That is 0. In natural numbers, which number is not having predecessor? That is 1. Okay, so this is about that whole numbers. Did you represent these whole numbers on that number line. Is it possible? Yes, it is possible. So just take that number line. So this is the number line for whole numbers. So the starting number, which number you have to represent it? Yes, 0. Why? Because whole number set is starting with the number 0, no? So 0, 1, 2, 3, 4, 5, 6, 7 and so on. Okay. So once observe that number line and tell me that answer here. Which is the smallest whole number? Here smallest whole number is 0. Yes. Here the smallest whole number is 0. What is the greatest whole number? Greatest whole number, is it possible to say? Not possible. Why? Because except that 0, the leftover remaining all numbers are natural numbers only, no. So in that natural numbers only we can't say that what is the greatest number. Again here natural numbers are included. Okay, is it possible to say here what is the greatest whole number? It is not possible. Okay, that's why here greatest whole number is not exist. Okay, so here 0 is that smallest whole number. Is it clear? So which number is not having predecessor means 0. What is the smallest whole number means that is also 0. Okay, in that starting video we discussed about that how many n-digit numbers are lying in between any two numbers. Okay, here also we can discuss that concept. What is that? How many n-digited whole numbers are lies in between any two whole numbers. Okay, here we can use that formula. What is that? B minus A plus 1 formula. Okay, here I will tell you that those two formulas. Okay, here we will discuss those 2 points. Let's say that let A and B are any two whole numbers. Any two whole numbers. Okay, let A and B are any two whole numbers, then the first condition is number of whole numbers lies from A to B. The condition is, the first one is number of whole numbers lies from A to B. Lies from A to B. So here the formula is B minus A plus 1. Okay, this is the formula we have to use for that number of whole numbers lies from A to B. Here A and B are any two whole numbers. Okay, this is the first condition. Now here the second one is number of whole numbers lies in between A and B. Number of whole numbers lies in between A and B. So here the formula is B minus A minus 1. Okay, here two formulas are there. First one is B minus A plus 1 and here B minus A minus 1. Why? Because here plus 1 and minus 1 means already I told. Again I am saying, see here, from A to B. From A to B. For example, this is A and this is B. From A to B means we have to include these two numbers also. We have to include these two numbers also. Okay, that's why that is plus 1. Okay, and come to this one, number of whole numbers lies in between A and B. Lies in between A and B. Here I am saying that this is A and this is B. So number of numbers lies in between means these three numbers only we need to count. That is the difference. From means we have to include these two. In between means we have to count these three. In middle, which one is there? That one only we have to count. Okay, that's why here we are subtracting these two. No, that's why minus 1. Why? Because minus 1, that one also I will tell. 1 will be included here. While you are counting the numbers from any two numbers, then here one of the number is included. Another number is there. No. If you subtract 1, then you will get that middle numbers. If you add 1, then you will get that from. Okay, that is the difference. So my first question is, how many whole numbers are lies? How many whole numbers are lies from 10 to 20? 10 to 20, how many whole numbers are there? This is my question. Okay, if you know that answer, then you can comment that. Okay, by using this formula, how to calculate this one? See, here B means that is the greatest number. You know that, right? So this is B and this is A. So B is equals to 20 minus 10 and here plus 1. 20 minus 10 plus 1. So 20 minus 10 is equals to 10. 10 plus 1 is equals to 11. So 11 whole numbers are there from A to B. Once count that. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So here how many whole numbers are there from 10 to 20? Here we got that 11 whole numbers are there. Okay, by using this formula we got that answer or not? Okay, now come to this one. How many whole numbers are there in between 10 and 20? So here you need not to count the 20 and you should not take that one as 10. Okay, 10 after 11 to here 20 before 19. 11 to 19, how many numbers are there? We have to calculate that. In between they are asking, no? That's why 11 to 19. How many numbers are there? Just see that. That is 20 minus 10 minus 1. So 20 minus 10 is 10. 10 minus 1 is 9. Okay. Once see that 11, 12, 13, 14, 15, 16, 17, 18, 19. So here we got that 9 only, no? Okay, that's why here the formula what we used that one, B minus A minus 1. So these two formulas we have to use to find further how many whole numbers are there from A to B and how many whole numbers are there in between A and B. Okay, not only for whole numbers, we can apply this formula for that integers. Next for that natural numbers also we can use this one. Okay.